Hi friends, today I am giving a lecture on differences between divide and conquer and dynamic programming methods. Okay, so here divide and conquer and dynamic programming both are algorithm design techniques. Okay, first we can take the divide and conquer technique. In divide and conquer technique, so it is one of the easiest algorithm design technique. It is very useful to understand. So in divide and conquer technique, suppose we can take a problem. So if the problem is very small problem, then we can directly solve that problem. Otherwise, if the problem is very big problem, so then that problem can be divided into some smaller subproblems. So each and every subproblems can be solved independently. Then we can combine all the solutions of the subproblems. Then we can get the solution to the original problem. So this is the technique we have to follow in divide and conquer technique. So in divide and conquer technique, mainly it consists of divide phase and conquer phase. In divide phase, the problem is divided into some smaller subproblems and can be solved each and every subproblem independently. In conquer phase, once the subproblems are solved independently, then we can combine all the solutions to the subproblems. Then we get the solution to the original problem. Next, in divide and conquer, so where the split point is there. So in divide and conquer technique, the given input is splitted into two parts at a particular specified point. So that point is called as mid value. Okay, so the split point can be done at the middle point of the given input. So by using mid value, we can split the input list into two sublists until each and every sublist contains a single element. So how to calculate the mid value? Mid value is equal to low plus high by 2. Low plus high by 2. So by using this value, we can split the given list into two sublists. So this procedure is continued until each and every sublist contains a single element. Next, divide and conquer uses top-down approach. So the splitting process can be done from the top to bottom. Top to bottom. So we can say that divide and conquer technique follows the top-down approach. So in this one, in divide and conquer technique, recursive methods are used. Okay, so by using recursive methods, we can solve the given problem by using divide and conquer technique. Next, sometimes while solving the given problem by using divide and conquer technique, so duplication of subproblems may be done. Duplication of subproblems may be occurred. So if any duplication of subproblems may be occurred, then that can be neglected. Okay, so these are the points we have to keep in mind while solving any problem by using divide and conquer technique. Next, another one is dynamic programming. So dynamic programming is one of the algorithm design technique. It is somewhat difficult compared to the divide and conquer technique. So in the dynamic programming, we use the principle called as principle of optimality. So by using this principle of optimality principle, we may get the optimal solution. Guaranteely say that we may get the optimal solution. So what is principle of optimality? Suppose if a problem is a optimal problem, so then what are the sub-problems that may get from the original problem? All the sub-problems are also called as optimal problems. In dynamic programming, we can make more decisions. Okay, so we can make more decisions. So each and every decision is optimal decision. So then finally we are getting the optimal solution. Next, in dynamic programming, we can split the given input at every possible point. So at every possible point. So among them we may choose the best split point. Okay. Next, dynamic programming is more efficient than divide and conquer technique. When we are comparing to the divide and conquer technique, which is more efficient, dynamic programming is more efficient. So, but it is somewhat difficult compared to the divide and conquer for easy understanding. Okay. So in dynamic programming, so duplication in solutions is avoided totally. If any duplication can be done, that duplication is avoided. So in dynamic programming, suppose we can take one subproblem. So that subproblem can be calculated only once. So that value is stored in a memory. Stored in a memory or list. If any subproblem is occurred of the same type, so without solving that subproblem, we can take the result from the memory or list. So this is the main advantage of main advantage of dynamic programming. So in dynamic programming, sometimes overlapping sub-instances may be occurred. So overlapping sub-instances maybe is nothing but same type of problem can be occurred more than once. So without solve only one time the sub-problem is solved. So another time the same sub-problem occurred in the future. So without solving that sub-problem, so directly we can substitute with the resultant value that is stored in the memory previously. So this is the main advantage of dynamic programming. So these are the what are the examples of divide and conquer? So merge sort, quick sort, finding the maximum and minimum, binary search. What are the applications of dynamic programming? Multi-stage graph, 0x1 knapsack problem, traveling salesperson problem, single source shortest path problem, all pairs shortest path problem. So these are the examples of dynamic programming. So in dynamic programming, iterative methods are used, while in divide and conquer, recursive methods are used. That is one more difference between divide and conquer and dynamic programming. So these are the 5 differences between divide and conquer and dynamic programming. So first, in this technique, the problem is divided into some small subproblems. So these subproblems are solved independently. Finally, all the solutions of the subproblems are collected together to get the final solution to the given problem. So by using this point, we can understand that. So if the given problem is a very small problem, so then we can solve that problem directly. So if the given problem is a very large problem, so the given problem can be divided into some smaller subproblems. Each and every subproblem can be solved independently. So finally, we can combine all the solutions of the subproblems. So then we get the final solution to the given problem. Okay. Next, in dynamic programming, many decision sequences are generated and overlapping sub-instances are considered. So in dynamic programming, we can take many decisions at each and every stage. So each and every decision is optimal decision, because the main purpose of dynamic programming is to get the optimal solution to the given problem. Okay. Next one is overlapping subinstances. So in dynamic programming, suppose there are some subproblems are there. Each and every subproblem can be solved only once. So that result is stored in the table or list or in the memory. So in future, the same subproblem can be occurred. Okay, without computing that subproblem, directly we can substitute the value that is stored in the memory. So that can be done in dynamic programming. Next, in divide and conquer, duplication in subsolutions are neglected. Duplicate subsolutions may be obtained. So in divide and conquer method, sometimes duplicate subsolutions may be occurred. So if any duplicate subsolutions are occurred, that may be neglected. Sometimes they may occur duplicate subsolutions. If any subsolutions are occurred, that can be neglected. In dynamic programming, duplicate in solutions is avoided totally. So we can avoid duplicate solutions completely. Next, divide and conquer is less efficient because of rework on solutions. So divide and conquer technique is less efficient because the same subproblem can be occurred more than once. So each and every time, that subproblem can be solved. So that is rework on solutions. Again and again, we can solve the same problem. We can solve the same subproblems. Okay, so that is rework on solutions. So because of that reason, it is very less efficient. So okay, same task can be done multiple times. So because of that one, it is not an efficient. It is less efficient. But dynamic programming is more efficient than divide and conquer strategy. So here there is no rework of solutions. There is no rework of solutions. So once the solution can be obtained for a subproblem, so that result is stored in the list or memory or a table. So in the future, the same subproblem can be occurred without computing the subproblem. So the result can be substituted, that can be taken from the memory or list or table. Next, divide and conquer uses top-down approach of problem solving. So in divide and conquer technique, how the problem is solved? The problem can be solved from top to bottom. First, we have to take a list. So the list is divided into two sublists by using the mid value. Again, the sublist is divided into two sublists by using the mid value. Again, that sublist is divided into two sublists by using the mid value. So here in divide and conquer, we follow the top to bottom approach. But in the dynamic programming, so the problem solving is in bottom up fashion. So from the bottom, we have to calculate each and every sub-solution, and finally we are getting the final solution at the top. So therefore, dynamic programming uses bottom up approach. Next, divide and conquer uses recursive methods. So in divide and conquer technique, we follow the recursive methods, but in the dynamic programming, we follow the iterative methods. Okay. Next, divide and conquer splits its input at specific deterministic points, usually in the middle. So by using divide and conquer technique, we can split the given list into two sublists by using a mid value. So by using this mid value, we can divide the list into two sublists. Okay. So this can be done at a specific deterministic point. So that is usually in the middle. But in the case of dynamic programming splits its input at every possible point. So whatever the possible point is there, dynamic programming splits at input. Okay, rather than at a particular point. So there is no specific point is there to divide the given list into two sublists. So, but here there is a specific point is there to divide the given list into two sublists. So that is usually in the middle. But there is no specific point to divide the given input into two sub inputs, two sublists. So at each and every possible point is there, so we can divide the given input. So after trying all split points, it determines which split point is optimal. Okay, so there are several split points are there. So among that several split points, which is optimal, so that can be taken as the split point. After trying all split, it determines which split point is optimal. So these are the mainly differences between divide and conquer and dynamic programming. Last point, what are the applications of divide and conquer? So this is the sixth point. Examples. So examples of divide and conquer is merge sort, quick sort, and binary search. Okay. So what are the examples for dynamic programming? So 0 by 1 knapsack problem, traveling salesperson problem, all pair shortest path problem. Examples. OBST. So these are the examples for dynamic programming. So these are the main differences between divide and conquer method and dynamic programming. Thank you for watching this video. If you like this video, please subscribe my channel name DIVVELA SRINIVASA. DIVVELA SRINIVASA. So thank you.